Okay, friends, so we have been on a journey with rational expressions, and it's all been to try to figure out how to add and subtract them. So in previous videos in this series, I've talked a whole lot about how to find the LCD between rational expressions and how to write equivalent rational expressions with that LCD. So I'm assuming if you're watching this video that you feel comfortable with that. I would definitely suggest maybe trying to master some homework before doing this video. Because if you've got that process down, then the next part I think kind of comes together nicely. So we're just going to jump right into this, and I'm going to start with just a really simple example. So in the nicest case scenario, so I've got 5 over x minus 2 minus 3 over x plus 2. So this is your nicest case scenario that we would love to always have happen, but it basically never does, right? So when you have the same denominator between two rational expressions or fractions, then you can go ahead and you can just add or subtract the tops. So here's what's actually going on here. And so this becomes just 2 over x plus 2. Now, the one thing I want to say about this is that this is the answer. You cannot, do not do this. Okay? These two things do not cancel. I have other videos where I explain why, but a really easy way to convince yourself of that is to think about the fact that x actually represents something. If you were able to actually cancel out the 2's, then you should be able to put in any number for x and still be able to cancel those 2's. So I just really quickly want to actually show you this because I think this is a really common error for people. So let's compare the idea of 2 over x plus 2 over 2 over 2x plus 2. Okay, so first of all, we've talked about in other videos that x plus 2 and 2, these are actually two totally separate factors. When I look at this problem here, so the thing I notice is that I could actually factor out a 2 from the denominator. So these are two vastly different problems. And when you have the same two factors, that's when you are allowed to cancel out things. So this you would be able to cancel out, and then this would become 1 over x plus 1. So that's one way we could think about it. Another way that we could think about this, I'll erase this. So like I said, if you're canceling out the 2's, then if you plug in a number for x, that reasoning should still hold. So let's just pretend for a second, I'm going to use the number, how about x equals 5, okay? So I've just chosen a totally random number here. So if I take x equals 5 and if I plug it into this first equation, so this becomes 2 over 5 plus 2. So I plugged in x equals 5, this becomes 2 over 7. I cannot simplify 2 over 7 anymore, right? So it would be wrong of me to cancel out the 2's and call this 1 over x, because then in plugging over 5, this would say that this would just equal 1 over 5. 1 over 5 and 2 over 7 are not equivalent, okay? Now, let me bring this example full circle. So let me now plug 5 into this. Okay, so if I plug 5 into this, this becomes 2 times 5 plus 2. So this becomes 2 over 10 plus 2. So this becomes 1 over 12. Okay, or sorry, 2 over 12. Okay, so that equals 1 over 6. So this simplified to 1 over 6. Now, if I use the simplified version of this where I canceled out my 2's, so remember, this equals 1 over x plus 1. So if I now plug in 5 in for x, check it out. It is 1 over 6. These two things are equivalent. So this is what I mean. Your cancellations have to actually make sense. And this is a way you can convince yourself of whether you should or should not cancel. There's a couple different ways you can think about it. I have other videos. I think I'll drop a link in the description to one where I kind of explore this because some people are just really prone to this particular error. And if you find that you get cancellation happy, that's what I like to call it, you're cancellation happy, and you cancel out things that you're not supposed to, you've really got to try to understand why you shouldn't do that to prevent yourself from making that mistake. It's a really simple mistake that I see very, very often. So now I want to talk about what do we do when we actually have a problem where we have two different denominators. So this is what we've been building up in the other videos, right? So in this case, the first thing that I know I'm going to want to do is I'm going to want to find the LCD, and I know with x minus 4 and x that this will just be x times x minus 4 for my LCD. So now what I want to do is I just want to show you two different ways of how you can approach a problem like this. Because the thing is, I find that these types of problems, I think like one of the hidden challenges in them is that it's actually a little bit of you versus how you store information and how you process information. And so one of the tricks, if you find things like this to be difficult, is to figure out what's the best way to organize it so that you don't miss anything, right? So I think it's really kind of a challenge in how you organize things. Okay, so here's one way that you could do this. So I like to call this like just doing everything right in the problem. So I have 5 over x minus 4, and I just say, okay, so what do I need to multiply that by? So I know that I need to multiply that by top and bottom by x. And then, so notice how I continue on with the problem. I write 7 over x. And now what I'm going to do is I'm going to multiply the top and bottom by what this fraction needs. So I am continuing on with the problem, and I'm just kind of shoving into this all of the other work that I need to do for the LCD. Now, if you find this to just be overwhelming, too much detail, you don't like this, that's not a problem, and I'm going to show you a second way that you could do this. So maybe what you'd want to do right now is just watch the two ways I present this, and then write down the way that makes the most sense to you, that you like the best. Or if you come up with something that's maybe just a little bit different that helps you organize the information, that's fine too. Okay, so this is kind of the way that I personally prefer to do this. And so now what I'm going to do is I'm going to write 5x plus 7 times x minus 4. All of this over the same LCD. Because all of this work here, the whole point of this was to get me to the same LCD. And now I can write this in such a way so that I can see exactly what I need to be working on with the numerator. And notice I just took this plus sign, that's just what I dropped kind of in between, right? And now this allows me to see that I still need to distribute the 7. I can't cancel anything out yet. We don't want to be cancellation happy. So this is going to be 5x plus 7x minus 28. So I distribute that 7 in. And then x times x minus 4. Okay, and so now this becomes 12x minus 28 over x times x minus 4. Okay, so there's our answer. And I can't really cancel like anything else out. So if I tried to cancel something out, let's say if I factored out the 2, this would become 6x. Let's see, actually I can factor out 4. So if I factor out 4, this becomes 3x minus 7 over x times x minus 4. So I've factored 4 out of the top here. There's nothing here that will cancel out. So I actually, you like don't have to factor out the 4 unless you want to make sure that nothing cancels out. So if you already know that nothing's going to cancel out, you don't have to go any farther with it. If by chance I factored out 4 and this became something like x minus 4, then I would cancel them out, but nothing actually cancels out in this case. So not necessarily to do this. Okay, so just appreciate how this worked. So this was everything all in one line, and I just kind of kept it all together. So I just want to quickly show you a second way that you could approach this, because I think some people just find having all this information, I think they find it daunting. So there's a way you could also break this down into smaller steps. Okay, so if you want to break this into smaller parts, what you can do is first you can just write down the first fraction, and you can kind of treat it how we've been treating working with the like equivalent LCD problems. So write it down as a separate fraction, figure out what you need to multiply by, and then do that multiplication. And then we'll repeat it for 7 over x. So this one I need to multiply by x minus 4. So this becomes 7x minus 28 over x times x minus 4. So now I've broken this just into smaller pieces, but I have to remember at the end of the day what I need to do is I need to add them. So I need to add this and this. So now I'm going to take those pieces and put them together and just collect any like terms, so that this becomes 12x minus 28 over x times x minus 4. So I think it's really important that you decide how you want to kind of organize this information in a way that you get it consistently correct. And that would be the way that I would commit to doing your work as you're practicing these at home. Okay, so let's keep going now with this idea. So I have this next problem, and I feel like we've kind of talked about this now in different ways of approaching this. So I really want to recommend that you pause the video here, and let's just make sure that you've got this down. Hit play when you think you have completed this. Okay, so in this case, so the largest number that divides into 12 and 8 is 4. So 12 is going to be 4 times 3. 8 is going to be 4 times 2. So for the number part of my LCD, that's going to be 4 times 3 times 2. So that's 24. So let's see. So my LCD is going to be 24x cubed y squared. Okay, cool. So I will get rid of this other information, and now we can go ahead and move forward with the problem. So I like to do everything just in the problem, but if you chose to do it a different way, that's totally fine. So I've got 12xy squared. So what do I need to multiply that by to get to 24x cubed y squared? Well, I need to multiply that by, let's see, 2 and x squared. Looks like it's what I'm missing. Okay, so that one gets multiplied by 2x squared. And the second one, let's see, this needs to get multiplied by 3y. Cool. So this will be 10x squared minus 21y over 24x cubed y squared. And there's nothing that I can factor out here. Once again, I can't go cancellation happy. I can't, if I could factor an x out of the entire top part, then I could cancel it out. But since I can't, this is as far as I can go. So I think that that's actually one of the big challenges of this, is just kind of also knowing when you need to stop. Okay, so let's keep going with this idea. So again, I really want to encourage you, the more that you can do these on your own, the more on fire you're going to be when you're doing your own work. So, I know it can get a little tedious with the videos, but I mean, really keep at it, be proud of yourself. Like if you're on fire, let's keep going. And if you've been kind of hit or miss, let's see how you do with this one. It's really just a thing of practice, practice, practice. Sometimes some days are better than others. So let's do it. Okay, so for this one, my LCD is just going to be x plus 3, x minus 3. So this one's actually going to be nice and straightforward, because the only fraction that I have to multiply anything by is the first one. I just have to multiply the first one by x minus 3, because the second fraction is already in that LCD form that we wanted. So this was already in the x plus 3, x minus 3 form. So that's cool. So let's see, this becomes then x squared minus 3x minus 2 over x plus 3, x minus 3. And that cannot be factored. So that's going to be as good as it gets. So cool. Okay, and I've thrown a little challenging one on here for the last one. So let's give this one, this is the last one you've got to do in this series. So give it all you got. Hit play when you're ready. Okay, so I truly hope that you tried this one totally on your own. Again, if you can do something like this on your own, then you're going to do pretty well on your homework or other things if you're studying for a test or whatever. So I am going to go ahead and factor this. Okay, so let's see. How does this factor? This will factor as x, let's see, x minus 8, x plus 5. Yeah. Okay, so my LCD, I'll just write it over here. My LCD will be x plus 5, x minus 5, x minus 8. I'm running out of space, so they should all be together, but running out of space. Okay, so let's go ahead and multiply. So I am going to go ahead and multiply this first fraction by x minus 8. Okay. And this second fraction, I need to multiply by x minus 5. Okay, so remember to distribute everything. So this x I'm going to distribute in here. So this becomes x squared minus 8x. And, you know, actually, I want to show you a slightly different way to do this now that I think about this. Okay, so what I want to do is, what makes this problem hard, actually, is that this minus sign is in front here. So let me clear a little space just so we can appreciate this. Okay, so the thing about the minus is you actually have to be very careful with this. So I have a best habit to get into. So let's rewrite this so that I can see. So once I see the minus, I usually do this. Okay, so I am going to just rewrite the work that needs to be done all over my desired LCD like this. And so look at what this does for me. Now I can see that I'm distributing -5 into this, because this is going to also impact the signs. So you want to make sure that you're properly capturing this, which is why I like to write everything on one line, and then that like ensures that I'm going to get all my signs right. So this now becomes x squared minus 8x minus 5x plus 25. It's a really common error to miss that plus 25 because you miss that minus sign. And so now I can see my like terms. So this is going to be x squared minus 13x plus 25, all of that over this whole LCD. And this will not factor any farther, so that's as good as it gets. Okay, so I do have other videos with more examples and all that good stuff. So this is something kind of intended to get you started. If you still feel like you need a few more examples or you want to see some more instruction, please check out my other videos. And if you found this helpful, I'd love it if you gave the video a like, or if you subscribed to the channel. I've been doing math for too many hours today, guys. And I will talk to you guys in the next video. Thanks for watching.